Hi everybody, welcome back. Today we're going to look at the law of sines again, day 2, and I just want to review the formula first. So in any triangle, if you take the sine of each angle divided by its opposite side, those ratios will all be equal. So for example, the sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is equal to the sine of angle C divided by side C. So we use the law of sines to solve for missing measurements on triangles. We use it when we're given information that is an angle and an included side and another angle given, or when we have an angle, and a non-included side given, and then we also use it when we have a side, and a non-included angle, which is a little bit unique, and we're kind of going to talk about that third scenario today. So today we're going to talk about the scenarios where no triangle exists. So it's possible with the given information that either no triangle could exist or possibly two triangles. Today we're going to talk about the no triangle scenario. And this only happens if you are given side-side angle and then certain things happen along the way. So we're going to look at number 5. We're going to solve the triangle. We're going to find all the missing measurements. We're going to round to the nearest hundredth. Because there's no picture, the first thing we're going to do is draw a picture of this triangle ABC here. Okay. So in triangle ABC, angle A is 51 degrees, side A is 24, and side B is 32. So first thing I'm going to do is draw that. And I'm not really concerned about the actual lengths and angle measures, so my picture isn't always accurate, but it's more about the relationship. So angle A is 51 degrees, side A, which would be across from angle A, is 24, then side B, which is across from angle B, is 32. Alright, so we need to solve for angle C, angle B, and side C. Alright, so here we go. We'll move this out of the way, and we are looking at having this ratio set up already. The 51 degrees is across from the side 24, so that's for sure going to be in our ratio. And then notice, or a proportion, notice that 32 is given, but I don't know the angle opposite, so I'm going to use that other proportion. Ratio. But notice how I don't have angle C, nor do I have side C, so I can't really use that one in the proportion. So I'm going to go ahead and circle this one, so we're going to use that one. So when we set it up, this is what it looks like. We have the sine of 51 divided by 24, which is equal to the sine of angle B over its opposite side, 32. So we're going to go ahead and cross multiply. So 32 times the sine of 51 is going to be equal to 24 times the sine of angle B. So first we're going to have to get the sine of B by itself, so we're going to divide out this 24 over here. And then I'm going to grab my calculator and we're going to calculate this. So we have, turn that on, and there's a little bit of glare, so I'm going to move it up a little bit. So 32 sine 51, close that parenthesis, divided by 24 is 1.03619. So I'm going to go ahead and write this down, but I'm going to put at least 4 decimal places rounding correctly. So 1.0362 equals the sine of B. So if we're trying to solve for angle B, we would then perform an inverse sine to both sides. And so on the right-hand side, the sine and the inverse sine cancel, so we're left with angle B. But now I want you to watch what happens when we try to take the inverse sine, so I want you to be able to see this, of 1.0362, and notice how you get an error. Okay? that means that there is no angle that exists if the 51 degrees is across from the 24 and that the side opposite of B has to be 32. Okay? So when you get this error on your calculator, that just means no triangle exists. So you could write no solution, which we symbolize with this 0 with the slash through it. Okay? So that is the no solution situation, and so that happens sometimes, not a lot, but sometimes. All right? The other thing I want to do is actually do this word problem down here, number 7. So you can look online at my notes for number 6. I'm just not going to videotape number 6. But if you look at number 7 on your note sheet, we're talking about you and your friend. All right, you and your friend are playing catch. You're 75 feet apart. You both see an eagle soaring above. The angle of elevation from you to the eagle is 64 degrees, and the angle of elevation from your friend to the eagle is 87 degrees. Find the distance between you and the eagle. Round to the nearest tenth. Draw, 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 draw. You always should be drawing a picture, okay? So basically, I'm sorry here, we'll get this situated. I want to draw a triangle, and what I have is you. Let's just put a Y there, and your friend are 75 feet apart. So I'm going to draw like this, and I'm going to put F there for friend. Okay? Up here in the sky, you both spot an eagle. The angle of elevation from you to the eagle is 64 degrees. The angle of elevation from your friend to the eagle is 87. So what that means is the eagle is more like about right here, kind of closer to your friend's side. So I'm going to draw this triangle, and I am going to put an E right here for eagle. All right, if you want, you can put a little flying bird right there. Angle of elevation, though, is going from this horizontal up. So the angle of elevation from you to the eagle would be this angle here, which is 64 degrees, and the angle of elevation from your friend looking up at the eagle is right there, and that is the 87 degrees. You and your friend are 75 feet apart, so that is this segment here. And the question is, what's the distance between you and the eagle? So I'm going to put an X right there. And that is the picture. Okay, so now I'm going to go ahead and just zoom in a little bit here. You don't really need the word problem anymore because we have our picture and we know what we are going to solve for. So when you look at this one, I want you to notice a few things. One, you don't have a complete ratio yet. So the 75 is missing the angle opposite. The 87 is missing the side opposite, which is what we want. And the 64 is actually missing the side opposite, which we don't really want. So what I need is to notice that I can find angle E here because of the triangle sum theorem. So what I know is that angle E plus the 64 plus the 87, that has to add up to be 180. So I'm going to quick grab my calculator. I am going to take 180 and I'm subtracting the 64, I'm subtracting the 87, double checking my work here, and I get 29 degrees. So that means that angle E is 29 degrees. So now I'm going to go ahead and put that in my circle, and as you can see, that completes one of the ratios. Then we want to solve for x, so we for sure have to use that one. Okay? So here we go. Setting up, let's start down here. Sine 29 over 75 is equal to the sine of 87 over x. So I'm going to go ahead and cross multiply, and we are going to get that x times the sine of 29 has to equal 75 times the sine of 87. We are going to divide by the sine of 29 so that we can get x all by itself. So that cancels. And we're going to get x equals, and here we're going to grab our calculator. Make sure you can see it with the glare. And we're going to do 75 sine 87, close that out, divided by sine 29 equals 154.49. 54. Supposed to round to the nearest tenth, so 0.5. We're going to label feet, and that is the distance that you are to the eagle. Okay, so just a word problem, got to draw a picture, set up your proportion, solve for the missing piece. Okay? Alright, so the last thing on this day 2 is a special formula. It is an area formula for a triangle that uses the sine of an included angle. So if you look at the description of this formula, in triangle ABC, the area of a triangle is half the product of the two sides and the sine of the included angle. Okay? So basically, we are looking at, if we have a triangle, we have to be given a side, and this included angle. All right, and if we have that, then this is the formula. We take 1/2 of the one side times the other side times the side of this angle that is actually included. So I know there's like ABCs here, and that's just to show the relationship here. So if this is angle C, this is angle A and B, that means that this is side A, side B. So you can see then, to find the area of the triangle, you take half of side times included angle. Okay. Now I want to do number 9, because I want you to see that you don't always have to have the letters ABC. So if you look at number 9, we're talking about triangle MEG. Angle E is 120 degrees. So when I draw this triangle, I kind of want to make sure it looks a little bit like it's supposed to. So here's angle E that's obtuse. That's your 120. So wherever M is, let's just say it's down here and G is over here. It doesn't really matter. But side G is 11 and side M is 7. So what I want you to notice is that you actually have this side, and the included angle. And then the formula for the area of the triangle is to do 1/2 times 11 times 7 times the sine of 120. Okay, so again, I'm going to grab my calculator here, move it up a bit, clear it out, and we are doing 1/2. So if you would like to, lighting is kind of weird here, but here we go. 1/2, so 0.5 times 11 times 7 times sine of 120, and we get 33.34197, blah, blah, blah. It says here round to the nearest hundredth, so the area is 33.34. They don't give me a unit of measure, so I'm going to put UN squared, because that would be units squared, whatever units they are. So that is using the special formula for area of a triangle, using that sign. And this formula you're not going to need to memorize. In fact, you won't have to memorize the law of sines either. So that's about it for law of sines for now. We are going to next start looking at the law of cosines. So off I go, and do me a favor. If you see someone without a smile, give them one of yours. It's free, so do it. All right, we'll see you later.